Let's do some questions on derivative, which are important from CBSE board examination point of view. So this is double derivative based question. Look at that. If x is sine t and y is sine p t, we have to show that 1 minus x square d square y upon dx square minus x dy upon dx plus p square y. Similar questions we have in NCRT, but this is little above than average, or you can call it a little higher order. You can call it's important for your IIT and JEE level also, along with CBSE. Okay, so how to take it? First of all, we know that whenever x is given to you in terms of another parameter which is t, and y is also given to you in terms of t, to find out dy by dx, first of all we need to calculate dx upon dt. Okay, so dx upon dt here we know that will give you cos t. Similarly, y is given to you sine of pt, and if I take the derivative of y with respect to t, it will give you p into cos pt using chain rule. Sine pt derivative is cos pt, then you find out the derivative of the angle, which is p. Okay, to find out dy upon dx, what we have to do, we will divide dy upon dt divided by dx upon dt. So we'll put the values p cos pt divided by cos t. Okay. Ultimately, we have to come to this kind of equation because we need to prove that. And for that, we need d square y upon dx square. But we will not take the derivative, double derivative at this point of time, right? Because it's not going to give you anything to get this result. We need to square. So that's why, each question is different in its own way. So we should practice as much as possible to get to know the kind of steps or the kind of method we should proceed with. So first of all, I'm going to take the square of this equation 1. It will give you dy upon dx the whole square and p square cos square pt divided by cos square t. Okay. Now, if you will see, the original equations were x is equal to sine t, y is equal to sine pt. I can have the same thing if I convert cos square in terms of sine square. How? We know that cos square can be converted in terms of sine square with the help of identity. So we are going to write down this as 1 minus sine square pt. Okay. We will divide again cos square t. So cos square t again can be written as 1 minus sine square t. Okay. Now we are going to replace it. We know that it's given to us that x is sine t. So wherever we have sine t, we are going to take x, and where we have sine pt, we are going to take as y. Right? So we are converting basically this in terms of x and y. And by converting in terms of x and y, it will become more simpler to us to take the derivative. Okay. So this is p square 1 minus y square divided by 1 minus x square. Right? And then we will cross multiply. And then it is p square 1 minus y square. Now to come to this, the result, what we have to show, we need d square y upon dx square. For that, we are going to differentiate with respect to x. So if I take the derivative, I know that I have to use product rule. So first of all, if I'll take the derivative of the first factor, it will give you minus 2x, right? And the second term, I'll keep it as it is, then plus 1 minus x square, I'll keep it as it is now and take the derivative of the second one by using chain rule. I'll write 2 into dy upon dx, and then further dy dx one more time derivative will give you d square y upon dx square. P square, I know that 1, p square is constant, it will come as it is, 1 is constant 0, and y square it's 2y dy by dx. Okay. Now, first of all, what I'm going to do, I'm going to shift this negative term other side. So I'll write minus 2x dy upon dx the whole square, then 2 times 1 minus x square, 2 dy upon dx into d square y upon dx square. Now p square into 0 will give you 0, and p square minus 2y, because I'm shifting other side, it will become plus 2y dy dx into p square equal to 0. Now, but if you will see the result is something else. P square, how will you come to know that now what should be done? Because P square we should have only with y. Now we'll see what extra we are getting here. I should have P square into y at the last term. So what is extra right now? We have 2 dy upon dx. One more thing we'll see. The rest of the things, are we getting the same? We should have 1 minus x square d square y upon dx square. So again from here we can see that it has to get divided by what? 2 dy into dx. So divide the whole equation. Okay? Divide the above equation by 2 times dy by dx so that we get the final result, required result. Okay? So if I divide it by 2 dy by dx, I'm going to have only minus x dy upon dx. If I divide this by 2 dy by dx, I'm going to have, yes, I'm going to have 2 times. Okay, this 2 is written extra, so this 2 has to be removed from here. Yes. Okay, because it was 1 minus x square 2 dy by dx d square y upon dx square. So when you divide it by 2 times dy by dx, it's going to give you 1 minus x square d square y upon dx square. Again, if you divide this, I'm going to have p square y equal to 0. And just rewrite this: 1 minus x square d square y upon dx square minus x. Okay, so this is the result. This is a slightly uncommon question. You will find at few places. So please take it very seriously and practice, because this is slightly different one. Okay. So just look at this question again and practice again and again, so that by the time you have board examination, you should be able to do it without any difficulty. Okay, come to the next one. Here, the similar kind of that x is given to you in terms of parameter t, and y is given to you again in the other variable in terms of other variable, that is t. Find out d square y upon dx square. So again, whenever you have such kind of expressions, you know that what do? We find out dx upon dt, a cos t, dy upon dt. Please take the derivative cos t minus sin t, log tan t by 2. We know that क्या लिखते हैं हम? 1 upon tan t by 2. Tan theta derivative is secant square. Here we have tan t by 2, so it would be secant square t by 2. Then angle is t by 2, that will become half, right? So just rewrite, because dx upon dt, this is given to you in a very simple way, a cos t. We have to make dy by dt also, simplify it more. So how? Minus sin t will remain as it is. Tan t, we know that we can write this as sin t by 2 upon cos t by 2. Cos t by 2 will go up, sin t by 2 will remain in the denominator. Secant square t by 2 can be written as cos square t by 2 into half. 1 cos t by 2 would be cancelled. Now we know that we have trigo formula. 2 sin theta cos theta is sin 2 theta. So 2 sin t by 2 cos t by 2 will become sin t. So we'll write minus sin t plus 1 upon sin t. Okay. I'm just solving dy by dt only. This will give you minus sin square t plus 1 upon sin t. Again, we have trigo identity. 1 minus sin square t, that will give you cos square t. Okay. So this is your dy by dt. Now, since we have to find out double derivative of dy by d, y, because single derivative is dy by dx and the double derivative is d square y upon dx square. For that, first of all, we'll calculate dy upon dx. How? Divide dy by dt, dx by dt, dy by dt we have obtained a into cos square t divided by sine t. Further, we are dividing it by a cos t. Okay, so a got cancelled. I'm going to write cos square t sine t into cos t. So here I obtained dy by dx as cot t. Okay, now since we have to find out one more time differentiation, so d square y, because dy dx का derivative जब आप दोबारा लेते हैं, what do you write? D square y upon dx square. Cot t derivative, you know that's minus cosecant square t. Now here children do common mistake. They just leave it like that. Please remember, we are taking derivative with respect to x, not with respect to t. So with respect to x है, so one more time take the differentiation of t with respect to x, that will become dt upon dx, right? Dt upon dx means we have to divide it by dx by dt, because if I'll take the reciprocal, it will give you dt upon dx, and already we have dx by dt, that is a cos t. Okay, I'm going to put it here, minus cosecant square t, and this is your a cos t. Okay, so minus 1 upon a cosecant square t, and this is your secant t, right? This is double derivative of y. I hope you have understood, and please keep practicing similar kind of questions. These are important for board examination. Thank you.